Good morning. Today we are simplifying radical expressions or simplifying square roots. Now, a radical is also known as a square root. Easy way to remember that is the word radical is usually said by surfers. So think of this as a big wave and a surfboard. Here's your wave and a surfboard, and they say radical. So this symbol right here is called a radical. You can go surfing on here. Underneath, whatever number you have, let's say it's number 16, that's what's called the radicand. So here's a radical, and here's what's inside. So that's what those two terms mean, just so you know. Also known as a square root. So it says the square root of a product equals the product of the square roots of the factors. What do you say in this calc? Well, I'm saying that if you have the square root of two things that are multiplied by each other, it's the same as taking the square root of each of them separately. So for example, if we have the square root of 4 times x, it's the same as the square root of 4 times the square root of x. Well, I know the square root of 4 is 2 because 2 times 2 is 4. So our answer is just 2 square root of x. So we're going to break down these square roots into parts that we know, like for example, square root of 4. So I know square root of 32, well, if you want, just divide by 2. If you're not sure, pick any numbers you want. Like for example, 8 times 4 is 32. So we really have the square root of 8 times the square root of 4 is square root of 32. Well, I know that the square root of 4 is really just 2. And square root of 8, well, I don't know what the square root of 8 is, but I know it's the square root of 4 times the square root of 2, because 2 times 4 is 8. And just like we said, the square root of 4 is really equal to 2, but I don't know what the square root of 2 is. So these are the three pieces that I have at the bottom here. So I have the square root of 4, which is 2, times this 2, times square root of 2. So this is my answer. However, I know that 2 times 2 is 4, so I have 4 times the square root of 2. All we're doing is simplifying the square root of 32. This times this, we know, is the same as 32. Well, square root of 4 is really just 2. This we broke down into square root of 4 and square root of 2, which we know this part's 2, and we don't know what that is. So these are all really just multiplied together. Let's try another one. 72. What multiplies to get to 72? If you're not sure, use your calculator, try dividing by 2, dividing by 3, whatever you want. I know 8 times 9 is 72, so square root of 8 and the square root of 9. So the square root of 9 I know is really just 3, because 3 times 3 is 9. The square root of 8, there's nothing that multiplies by itself to get 8, but I know 4 times 2 is 8. And the square root of 4 is 2, 2 times 2 is 4. Square root of 2, we don't know what that is, so here is my answer. We have 2 times 3, and then we always do the square roots last, times the square root of 2. So 2 times 3 is 6, and then square root of 2. This is as simplified as we can get. Alright, this next one we have letters and numbers. We can split this up, the letter and the number. So I know I have the square root of 9, and then I have the square root of x to the third. Well, here we have square root of 9. I know 3 times 3 is 9. And the x to the third is a little bit tricky. I know x to the third is really the same as square root of x times square root of x times the square root of x, because there's 3 x's there. We could do each one separate. But I also know that a square root and a square are opposites. So a square root and a square are opposites of each other. So if I take a look at two of these together, this is the same as the square root of x squared. So a square root and a square are cancel out and will leave us with just x. So these two combined to give us just x. So we have a 3, an x, and we have, this one didn't have a match, a square root of x. So again, just like here, the square root of 9 is 3, the square root of x squared is x. Just like multiplication and division are opposites, a square root and a square are opposites, or to the power of 2. Alright, last one. I know we have the square root of 25, and I have the square root of x squared. Well, square root of 25, I know 5 times 5 is 25, so this is equal to just 5. And the square root of x squared, a square root and a square cancel out and just leave me with x. So we have 5 and x, or 5x. Alright, on this next one, it says multiply radicals. So just going, we separated, for example, 16x squared into 2 separate pieces. Now we have those 2 separate pieces, so we're going to combine them together to make one big term. For example, if we combine these together, we have the square root of 6 times 6, which is really square root of 36. Well, what is the square root of 36? Well, 6 times 6 is 36, so it's just 6. This next one's going to be a little bit more complex. We can multiply whatever's underneath the square root. This 3 is not underneath, so that stays out front. And then underneath we have a 7, an x, a y squared, and then another x. So I'm just going to rewrite this. We have 7. There's 1x here and 1x here, so that's x squared, and then y squared. So I'm going to split up what's underneath my square root right here. I really have the square root of 7, the square root of x squared, and the square root of y squared. And don't forget we have the 3 out front. So square root and a square cancel out, so we just have x. This just leaves us with y. Square root of 7, I have no idea what that is. It's still square root of 7. So we have 3, an x, a y, and the square root of 7. Always put your square roots at the end, because otherwise it looks like the other numbers are underneath the square root, and they're really not. They're all multiplied together. Alright, same thing on this next one. Everything's under the square root, so we can multiply it all together. We have 75xy and 2x to the third. So here, 75 times 2, I could make this 150 if I wanted to. We have x to the third here and one more, so we really have x to the fourth. And we have just a y there. So we've taken care of everything. These were all multiplied together. And now we can split this up. This is really the square root of 150, and the square root of x to the fourth, and the square root of y. Y is just going to stay there. There's nothing we can do with that square root of y. We can't simplify it because there's not squared. This x to the fourth we could write as square root of x 4 times, but we know that anytime you have x squared 2 times, that's really just square root of x squared. And a square root and a square cancel and leave us with just x. So those two give us just x, and those two also give us just x. Then we have this 150 over here. I know that 75 times 2 is 150 because that's what we started with. So square root of 2, there's nothing I'm going to be able to do with that right now. 75 I know is 25 times 3, and the square root of 25 is 5. Square root of 3 I can't do anything with. So this one is a little bit more because we have the number, the x's, and the y's, but we can simplify all of it. We have a 5 out front. We're just dealing with just our letters and numbers that are all by themselves, 5. And we have an x and another x. Then under the square root, we have a 3, a 2, and a y. So the only thing I can do is simplify my x's here. This is really 5x squared, and then 3 times 2 is 6. So this would be the best answer. We're trying to get whatever's underneath the square root as small as possible. And we did. We simplified from these big numbers all the way down to just the 6y under the square root. Alright, now we're going to multiply some more radicals. Same thing, it's all multiplication. The 4 is out front though. The only things underneath the square roots are the 3x and this x. So this underneath the square root is really the square root of 3, and then we have 2 x's here, so we could write them each separately if we wanted to. I don't know what the square root of 3 is, so I'm just going to leave it like that. We also have this 4 out front. Square root of x times square root of x, I know is x squared. There's 2 of them. And a square root and a square are opposites, they cancel out and leave us with just x. Just like if you had, for some of you that that's confusing, the square root of 4 squared would be like taking 4 squared, which is 16, and then taking the square root of it, which is back to 4. So we can cancel out the square root and the square, and it'll just leave us with whatever's underneath, 4. So writing what we have a 4, we have an x, and we have the square root of 3. I would like for you to try this next one on your own, and then see if you got it right. So far we can combine everything together because it's all under the square root. 2x to the third and another x. So if you want, we could multiply and make this x to the fourth. Doesn't matter if you split it up anyways. We have square root of 2, and we have square root of x to the fourth. Well, x to the fourth is really square root of x 4 times. Some of you might want to think, hey, it's really square root of x squared only 2 times. And yes, you're right, that would be the same thing as well, kind of simplifying or skipping a step there. This we can't simplify, that is what it is. But every time we have 2 of these, this is really the square root of x squared. So the square root and the square cancel and leave us with just x and just x. So we have x, and then we have the square root of 2. So this is really x squared, square root of 2. I know this is a lot, I'm going kind of quick, so please make sure you pause and ask questions if you have any. Alright, next we're going to do the same thing. It says use the quotient property of radicals, except we have one extra little different step here. It says the square root of a quotient equals the square root of the numerator and the denominator. So for example, if you have the square root of a over b, it's the same as square root of a and square root of b. It just says a has to be greater than 0 and b has to be greater than 0. So let's take a look here. We have this is really the same as the square root of 13 over the square root of 100. Well, we know the square root of 100 is going to give us a nice number. 10 times 10 is 100. So we know that's 10 on the bottom. And on the top we have square root of 13. We simplify that as much as we can. We can't simplify 13, it's a prime number. Then our next box, our next problem, square root of a fraction is the same as the square root of the top and the square root of the bottom. Well, a square root and a square are opposites, so those cancel out, and we have the square root of 7 over x. And our last one, same as the square root of what's on top and the square root of what's on bottom. Well, square root of 1, we actually know what this is. We don't need to leave it as square root of 1. Isn't 1 times 1 just 1? So that's really just 1. And our square root and our square cancel, leaving us with just y. So our answer is 1 over y. But if you notice back here, all of these had just a regular number on the bottom, or a letter, 10, x, and y. When we write square roots or radicals, we need to have the square root always be on the top of the fraction. We can't have a square root on the bottom. So it says, how do we eliminate a radical from the denominator of a radical expression? We need to, what it says, rationalize the denominator. Make it a normal number. It's irrational right now, square root of 3, I don't know what that is. we need to rationalize it or make it a nice counting number on the denominator. So how do we do that? Well, in the past, for example, if we had a fraction 1/2 and I wanted to change it, but keep it the same, if I multiplied it by 2, I'm changing the fraction, but isn't 2/4 the same as 1/2? So I really multiplied by 1. 2/2 is just 1. So I can multiply this by 1, it'll stay the same fraction, it'll just look different. So if I multiply this by 1 in the form of square roots, we can get the square root on the denominator to go away. Because we know if we multiply by a square root of 3 on the bottom, square root of 3 times square root of 3 is really square root of 9, which is just 3. So I'm going to multiply by the square root of 3 on the top and the bottom, because this right here is just 1. It's the same number on the top and the bottom. So if I multiply by square root of 3 over square root of 3, I get 1 square root of 3, or just square root of 3. And on the bottom, square root of 3 times square root of 3, just like we did the other time, is really the square root of 9. And I know the square root of 9 is really just 3. So our answer is square root of 3 over 3. We have rationalized the denominator, made it a nice solid whole number. We're going to do the same thing here. To get rid of the denominator with the square root, we're going to multiply by 1. This time I'm going to multiply by square root of 7 over square root of 7, because I know square root of 7 times square root of 7, it's going to be able to eliminate that because that's a square root of now 49. On the top I have 5 square root of 7. They're just multiplied next to each other. Hopefully you know the square root of 49 is really just 7. So we have 5 square root of 7 over 7. So hopefully you're getting the drift here. If we multiply the same number under the square root, it's really just going to be that number without the square root. Same thing here. If you wanted to write this another way, you could have had on the bottom square root of 7 squared, and they would have canceled out and left you with just 7. Alright, same thing but with a letter. To get rid of the square root of x, we're going to multiply by square root of x and square root of x. So on the top, 1 times the square root of x is still just square root of x. You can put a 1 in front if you want, it's not going to do anything. On the bottom we have square root of x times square root of x, which is really square root of x 2 times. So a square root and a square are opposites, they cancel out and leave us with just x on the bottom. So we have the square root of x over x. It looks different, but just like these fractions, just like these fractions up here earlier, they look different, but they really are the same. So here's a couple more with rationalizing the denominator, except we have a little bit more in our square root on the bottom. So whatever is on the bottom, you're just going to multiply by that 2 times, which is really just 3b over 3b, which is really just 1. So on the top, they're all multiplied under the square root, so we have the square root of 2 times 3b. And on the bottom, 3b times 3b. You guys, hopefully you're getting the drift of that. We're just going to have a 3b left over on the bottom, because this would give us the square root of 9b squared. Square root of 9 is 3. Square root of b squared is just b. So our last step is just to multiply what's underneath here. We'd really have the square root of 6b and then 3b on the bottom. You cannot cancel top and bottom unless they're on the outside of the square root, which this is not. Alright, next, same thing. We have the square root of 2x, so we're going to multiply by 1. Square root of 2x over square root of 2x. So that leaves us 3 square root of 2x. Notice the 3 is not under a square root, so it goes out front. And then square root of 2x times square root of 2x, this would really be the square root of 4x squared. But we know the square root of 4 is 2, and the square root of x squared is x, because the square root and a square there would cancel out. So again, if you have the same thing under the square root and it's multiplied, it's just whatever's under there without the square root. So this is our answer. Can't simplify anything, so we're done. And back to the whole thing being under the square root. Remember, if you have a fraction, it's the same as the top being under the square root and the denominator under the square root. So the square root of 4 is really just 2, because 2 times 2 is 4. The square root of 52, I don't know what that is, but I'm just going to leave it as the square root of 52 for a second. So we have 2 over the square root of 52. And now to get rid of that square root of 52, we can multiply by 1, or in the form of square root of 52 or over square root of 52. So we have 2 square root of 52 over 52 times 52, or this is the same as the square root of 52 2 times. Well, what really happens here is the 52's cancel out, and we have 2 square root of 52 over 52. Well, we can do a little simplifying here. First thing we can do is simplify the square root of 52. I'm just going to write it over here. This is really, if I divide by, let's try 4 maybe. If I divide by 4, 4 times 13 is 52. So I know the square root of 4 is 2, so it's really 2 square root of 13. So this 2 is already there. And 52 is also 2 square root of 13 over 52. Well, on the top, 2 times 2 is 4. On the bottom I have 52. So the only thing I would say we have left to do is see if we can simplify the 4 over 52. And we just did, we know 54 divided by 4 is 13. So if I divide by 4 on the top and on the bottom, we get 1 square root of 13, or just square root of 13, over 52 divided by 4, which is 13. I know that one was a lot of work. If that one was a little confusing, that's okay. If you could guess it from a multiple choice question, that would be awesome. Alright, the last part here is adding and subtracting radicals. You cannot combine what's under the square root unless you're multiplying. So think of this, for example, like 2x plus 6x. Total we have 8x. The x didn't change. Same thing here, we have 2 square root of 2 and 6 square root of 2. They're both square roots of 2, so total we have 8 square root of 2. Alright, on this next one we have 1 square root of 5 minus 6 square root of 5. So how many square roots of 5 do we really have? Well, 1 minus 6 is negative 5 square roots of 5. Alright, this next one, we don't have the same number underneath the square root. That's like trying to say 2x plus 3y. What do you have? Well, you can't combine them. They're not like terms. So we need to simplify this 63 if we can first. I know 9 times 7, that's 63? Yeah. So square root of 9 times the square root of 7 is really square root of 63. So the square root of 9 is really just 3. And we have the square root of 7. But there's also this 3 out front. So we really have 3 times 3 is 9 square roots of 7 plus 2 square roots of 7. Now they have the same square root, so 9 and 2 make a total of 11 square roots of 7. So if you don't have the same number under the square root, see if you can get it to be the same. Alright, next one here, we have 3 different square roots. We have the square root of 12, square root of 3, and square root of 6. So let's see if we can simplify any. I'm going to start with the first one. I know 12 is 6 times 2, or even better, since you know 4 is a perfect square, 4 times 3 is 12. So then I would have here 2 and square root of 3. If you didn't think of that right away and you did 2 times 6, that's fine. Then we know 6 is the square root of 2 times the square root of 3. So when we have 2 of the same ones here, we know the square root of 2 times the square root of 2 is really the square root of 4, which is really just 2. So if you see 2 of the same square root right there, that's really equal to just 2. And then we have the square root of 3 over here. So what we have 2 square root of 3 plus 6 square root of 3. And this 6, if I divide that, the only things that multiply in are 2 and 3, and I can't make either of those smaller, so that would just go back to what it is right here. So we also have plus 2 square root of 6. So our only like terms we have are these two. 2 square root of 3 plus 6 square root of 3 is really 8 square root of 3 plus 2 square root of 6. We can't combine these, so we just need to write them next to each other like x's and y's. Alright, last couple here. The last step is to multiply, and we've done some multiplying already. When we have two terms by two terms, just like we've done in the past, we're going to draw a box to multiply. Just like our last chapter, we have 4 minus the square root of 5, and we have 1 minus the square root of 5. So I know 4 times 1 here is 4. Negative 1, really, times 1, just the numbers out front, we have negative 1. And then this is just still the square root of 5. We didn't have 2 square roots, so it just stays the same. Just like when we multiplied with x's, we always multiply the number out front first, so negative 1 times 4 is just negative 4. And then the square root of 5, there's nothing to multiply it by. We already multiplied the numbers out front, so it's just square root of 5. But then we have a negative 1 times a negative 1 out front makes a positive 1. Square root of 5 times square root of 5. Square root of 5 times square root of 5 is really the square root of 25. Because 5 times 5 is 25. And the square root of 25 is just 5. So we have 1 times 5, which is really just 5. So if we write all of this out, we have 4 minus this 1 square root of 5 minus 4 square root of 5 plus 5. So we're going to combine our like terms. Well, 4 and 5 are just numbers, so that gives us a total of 9. Then we can combine our square roots of 5. We have a negative 1 square root of 5 and a negative 4 square root of 5. So total, that's a negative 5 square root of 5. This is our answer. We cannot combine the number with the square root. It doesn't matter if you put the square roots first. If you put negative 5 square root of 5 plus 9, that's fine, but the square root's only over the 5, not over the 9. So either way, those are the same thing. Next, we're still multiplying, but this box is just 2 by 1, because we have the square root of 5 times 5 minus the square root of 5. Lots of 5's. So this is really 1 square root of 5, so 1 times 5 is 5. Square root of 5 is still just square root of 5. And then 1 times negative 1 is negative 1. And then square root of 5 times square root of 5, we just did that up here, it's 5. So we have 5 square root of 5, and then negative 1 times 5 is negative 5. So we can't combine these together, because this has this multiplied by a square root, this is not. And then last, we have this in parentheses 2 times, so we'd really write 2 square root of 5 plus 7 2 times. 2 square root of 5 plus 7. So I'm going to draw my box so I can multiply because it's 2 terms by 2 terms. So let's see here. We have 2 square root of 5 plus 7. 2 square root of 5 plus 7. So again, multiply the numbers up front first. 2 times 2 is 4. Square root of 5 times square root of 5. Again, we did that right here. It's really just 5. Not 45, it's 4 times 5, which is really 4 times 5 is 20. So I'm just going to erase that and write 20. We really did 4 times 5 there. And then in the next box, 2 times 7 is 14, and we have a square root of 5. Again, 7 times 2 is 14, and we have a square root of 5. And then 7 times 7 is 49. So if we want to write this all out, we can. I'm just writing out each term. But if you can combine it from the boxes, that works as well. 49 plus 20. 49 plus 20 is 69. And then 14 square root of 5 and another 14 square root of 5 is 28 square root of 5. Can't combine them because one has a square root and the other doesn't. Alright, your homework is 11.2, simplifying the expression, some with fractions on the bottom, and then a couple on the back as well. I'm going to have you cross off. Actually, you can do both of these. It's really just plugging in a number in and solving it using your calculator because it says round using the nearest hundredth. So the only thing you need to be careful is the difference between inches and feet. Good luck!